7.
Model it with exponential.
Alright, so like I said, we start this stuff out again by working really fast, solve an equation given a set of points, following a specific modeling. We're going back to exponential graphs, exponential growth, exponential decay. When we did that, we wrote the equation of this y equals a times b to the x. So that means I'm going to give you a pair of ordered pairs, redundant, a set of ordered pairs. That sounds better. I'm going to have you write the equation. Okay? So good luck with that. Welcome. So let's use y equals a times b to the x. Ordered pairs of 1 and 6 and 3 and 24. Yeah, I know. Sometimes you get the little lines there. So we know x and y, and we're going to solve for a and b. Winds up being a system of equations very similar to what exactly what we did with geometric series and stuff.
Then how come they put it 3 chapters away from each other?
You get that.
Wait, is that
Right.
subtraction?
Times.
Does it
Just
matter-
like we've done before. Yeah.
I'm sorry. Does it matter if you just write AB or do we have to have assignments?
No, you can write AB. I just write it out because I know it's a times b to the x.
And then substitution.
Yeah, we'll use substitution. We're going to get a by itself. So divide by b. Substitute in here. B cubed over b is what?
B squared.
So b there.
Be that,
Get it because you're not around.
Ah!
B over B squared because you're not there.
Do I have to do plus minus here? No. When I have base exponents, am I going to have a negative base? No. Base. How low can you go? Death row. Once back again is the uncannibal rhyme animal. The uncannibal D, public enemy number 1. By vote set free, and I've got none. And I tell them I never ever had a gun with the reps that Terminator X spun. Yeah, that's right.
I like to have fun.
That's Bring the Noise by Public Enemy, in case you were wondering.
I will.
Yes, ma'am.
So why is it that you can't, that you don't need plus minus?
Our base, when we're dealing with exponential problems here, your base is always positive. Remember, our b value was always greater than 1.
Oh,
Our b, I'm sorry, the absolute
B.
value of b was always positive. B was always positive. Okay.
Nice.
So now what do you do to find a? Substitute back in. What's up?
Who is it? Show yourself.
I thought you had it.
Who is this? Maybe I did, but I just want to check.
Did you see a phone anywhere? Anybody?
Wait, finders keepers.
So a is 3. Function y equals 3 times 2 to the x. 6 divided by 2.
Can we reset to the 6 over b is equal to a? I'm not really sure what we did.
I divided by b. I got a by itself. I'm solving, what we're doing here at the top is we're solving what's called a literal equation. When you're solving a literal equation, that's when you have multiple variables and you're trying to isolate one of them.
Oh.
So we're just isolating a. Sure.
So why was it that we found B first? Is that just because it was to the power of 1 or?
Yeah.
Okay. So
That's usually what happens here. Sir.
You have to, okay, so you used the first problem with the 6 and you found B for that one. Then you substituted into the second one.
Yeah.
So can we not substitute back into the first problem?
What do you mean?
Like, we found A, right?
Yeah.
Does that mean we can substitute for both of them or they not work?
Oh no. What we're doing, you're solving for b first, and you can put b here if you want.
Can you show your work?
It's just already isolated here. Why do more work?
Okay, I was just
yet. See what I'm saying?
Yeah.
Because it had that lower degree, which is quicker. That's all.
All right, thank you.
You can do it either way. It's fine.
I don't know, I was making sure I don't like forget something. And like, oh, I just did all of these.
Oh, why did I?
put my phone on it.
Where's my? Oh, it's not in sequence. Darn it.
I think I got it.
Yeah, I
I think it's broke. Your face is pretty.
Oh, nuts! I didn't put it in the sequence in here. Shoot. Oh well. There. Let's do the. I didn't say that.
Hey, Bryce. Hey, Bryce.
Normal.
I'm pretty sure.
These pants straight.
You wouldn't know. I know.
How are you, sir?
Hey.
Are you?
Good one, Charlie. Good one.
Nope. For neither of them. Nobody. So if I want to model power function is different. Power function is different. It's a times x to some power.
What was the previous one?
Now, the variable is raised to some power of b. So this is like saying 2x cubed, 7x to the third, something like that. The variable is still x, but the variable now is being raised to a power. That's why they call it a power function. Don't need to worry if I'm asking you to write an equation. I'll ask you to write it as a power function, or I'll ask you to write it as the other one. Exponential. So
Wait, so what's the difference?
We had a log base.
we'll have to log base something. Very good. So we have the ordered pairs 2 and 5, and at 6 and 9, substitute in 5 is a times 2 to the b. 9 is a times 6 to the b. Yes, ma'am. It's just a different. This is a instead of being exponential, this is a power function. They're two different functions. One's exponential because it's a b to the x, and this is power because x is raised to a power. Do the same thing. We're gonna get a by itself. So divide by 2 to the b power. So 5 over 2 to the b power is a. Substitute again. We get 9 is 5 over 2 to the b times 6 to the b. 6 to the b divided by 2 to the b is 3 to the b. So 9 is 5 times 3 to the b. How do I do multiplying by 5?
Divide by 5.
Divided by 5. So 9 divided by 5 is 1.8. Oh, this one's an easy one. It's easier to type it into the calculator. And now how do I get the exponent to drop?
Log base.
Log base
3.
3. Good. Log base 3 on both sides. Alpha window.
Alpha window, there you go.
0.54 if you're rounding.
Was it 0.535?
Yeah, so 0.54.
Yeah. If you go out to 3 decimals, you get a better sense of a model than you do 2. It's we're not trying to solve, for like we're not building things.
You can see these getting pretty gnarly.
Whoa, gnarly, dude.
Totally radical.
Sir,
If we wanted to, could we plug the
are you doing electrical work?
Can we substitute the 0.535 and the 5 into the base equal?
Yeah, if you want. That's how you figure out A. So now you take this value, substitute in here, and that's how you get your A.
Snap.
What's the answer?
3.45x to the 0.535, and that would be the model for that function. Okay. The weirdness of exponential growth style problems is that when you're looking at it, trying to come up with the model. So we need to look at an actual table to see how this works. And there's a nice, easy way to set them up. Okay? I'm hoping that solving equation-wise is pretty quick, right? Let's look at a table set of values and figure out what we're going to do with this. Exponential model, let's do an L1 and an L2 of this stuff. The table gives you the number in millions of cell phone subscribers from 1988 to 1997, where T is the number of years since 1987. Yeah, I bet you they went up exponentially. L1, L2. Put them in.
How do you get
I'm waiting for the trick. What's the trick?
I'll show you.
How do you get L1, L2 again?
L1, L2.
Stat.
Stat. Like, I was trying to get my table sets up. It's up a little bit.
Yep, 1901 again.
So what I'm doing right off the bat, what I'm doing right away is getting rid of the stuff that was in my, what do you call it? List. Thank you. You see that okay? So we hit stat, edit, and I want to do an L1. Yeah, stat edit.
It's like that.
Let me know you guys are ready, and I'll show you what's good. Remember, you also want to adjust your window so you can graph this and see this. I'd adjust my X parts of my window, maybe go 0 through 11, and then do my Y values. Bring this back up so you can see it. And then do my Y values maybe from 0 to 50. And then I'll do my 0 to 50, I might go by 5s on the graph so you can see it a little bit better.
Whoa, there's nice.
For L2, for the Y values.
Oh, you like.
I'll show you. Are we all got? Are we okay in the table stuff?
No, Mr. Murphy, I don't know why that's. Just like some thing.
I don't know. Give me a second. So I'm going to go to my window. I have an X minimum at 0, an X maximum at 11, scaling by 1, 0 to 50. I guess I also went scaled by 1. You don't really have to change it. I guess it's not a big deal. Now, if I hit my graph, it should show, oh, because I have something my Y equals. And I turn off this. Now, if I graph it, it looks like that. Everybody's graph kind of look like that?
It's going up.
It's a positive.
Down into the graph.
Down.
Did you find it?
What's your
I went 0 to 11 and 0 to 50.
Here's the real question, is that graph going down into the left or up into the right?
Yes.
Or is it?
Well, if it's exponential, it's got to start somewhere. Where did it start? It started at 87, so it's got to be moving up to the right.
Or you could start at 87 and go down. It could be.
No,
Don't go that way.
It could be a.
Oh, yeah, 2016.
That'd be
Here's the trick. This data set, guys, this data set's pretty easy to see that it's exponential because how the increase is increasing at an increasing rate. The way that you can show it graphically is by using natural log. What I want you to do, and this is the trick, take the natural log of your y values. So I want you to create a third column, L3. In L3, you're going to type in stat edit. In my third column, I'm going to type in the natural log of each of these. And I can actually do the calculation in the table. Just type in natural log 1.6.
It's actual button.
Yeah.
Do you have to close the parentheses?
No, you don't.
Woohoo.
Okay. I'll show you. If it's exponential, now, here's what happens. In order for you to see both of these graphs, you actually have to turn on a second stat plot. Okay? So once you get your data set in there, go to second stat plot again. And we're going to turn on plot number 2. Okay?
Are we supposed to change the marking?
What's that?
Should we change the marking?
You don't have to. And I'm going to turn on the plot 2. And then inside here, you're going to have the option of changing your list. We want our y values now to be L3. So what you do is you move your cursor down, and you have to change it to L3. Well, if you look at all your superscripts and your subscripts on the keypad, I believe you hit second 3, and it shows up as L3. Yep, you want L1 versus L3. Okay. You want L1 versus L3 then. And you do that to change your list here, all you have to do is hit second 3 because that's what the L3 is. Now when you graph it, you should get 2 graphs. I might have it. I think I typed in the wrong number here. What happens when you take the natural log of the data and you plot it on the same line, the natural log, if it's exponential, if it is a true exponential function, once you take the natural log of that, it should look linear graphically. It should look like almost a straight line then. That's how you're able to distinguish if something is going to be in fact exponential versus one of the other ones. So this one's a pretty good, obviously it's exponential, but it's a pretty good way of showing that it is. Yes, sir?
Could you tell, or what would it be if it wasn't exponential?
We could have logarithmic, and we'll talk about that later.
Well, like, what would, if we did the natural log, what would it show up as? Just a line? Or would it just...
It might be a curve or something like that. It should be close to linear. Yes, sir?
So what are we doing here exactly?
We're verifying graphically that we believe that something is exponential. If we believe something graphically is exponential, we take the natural log of the y values and replot. By doing that, you're undoing your exponent by natural log, and that should flatten it out, if you will.
Oh.
It should be linear.
So that's what that second graph.
Yes, sir.
Right.
So this, natural log is just base 10.
Well, how did somebody?
Well, you still have to. How do you figure out your exponents? It's like 2 to what power is 6? And that's exactly right. You have to worry about all the multiply out, and it became all by hand and tables and all that other stuff. Yep. Book O tables, those things were great. So now in this case, if I wanted to calculate the exponential, what button do you think we have to press? Not second calculate, we hit stat calculate. You're on the right track though. Hit stat, calculate, and now I have to look for expo because we're talking exponential. X, excuse me. X. I think it's 0, yeah. X reg. Hit enter. And now you just have to make sure you pick the right list. And if you're looking at an exponential model, it should, because you originally put in L1, L2, just make sure you're looking at L1, L2. Oh, that's fine. Sometimes this screen's a little bit different than the others, so just hit enter a few times. Excuse me.
Wait, we don't get that.
Yeah, it's like that list.
That's fine. Some of the newer calculators have a different options to them. Yes, sir.
What is this doing?
What's that?
What is this doing?
Right in the equation. So the equation that fits the data here is this, where your A value is 1.3 and your B value is 1.46. That's it. It is gross. It's very gross. Thank goodness we have calculators.
Yeah.
And that's what it does. The regression formulas on the calculators allow you to be able to do that.
If we had to do the long division for all this stuff.
Good luck.
It wouldn't even end it because you know.
And then if you had to estimate how many cell phones there were in the year 2000, well, this is going by, year 1 is 87, so you have to figure out year 2000 would have been, what, 13 years later?
13 years.
So then I'd say, I'd substitute, put this in my calculator, and look where x was equal to 13. And go from that. Okay? Questions?
No.
Just press some more buttons. Again,
How do you do the trick? What is it? You said second stat?
No, stat plot, then calculate.
Oh, okay.
you want to see, remember, because what you're trying to do here is in the graph itself,
Oh, you talking about that, sorry.
when you have an exponential graph, to verify that it's graph, you assume that your graph is exponential. If you take the natural log, and the natural log graph of that data looks linear, you're probably on the right track. That's the trick for these.
I put it in. I was just trying to figure out how to turn on the third one, but I think I just figured it out.
Maybe some of these to work on tonight. Well, Monday morning, I know.
Were these,
What are you talking about? I do
was
this in
this
Flex.
method included in that cheat sheet you gave us?
These are the same setups, but you have to remember that you're picking different methods.
Please don't.
Yeah, Monday during Flex is what this will.
Monday during. Adonis Johnson.
I'm just gonna get, can I just see that?